Hello students, welcome back to our channel. Students, in this video we are going to study about a very important topic from class 12th physics chapter semiconductors. This topic is transistor. Let's start. What is a transistor? A transistor is a semiconductor device that is often used for amplifying or switching electronic signals or electronic powers. We all know that a semiconductor chip is there in all the digital devices like mobile phones, like laptops, televisions, smart boards, smartwatches, and one of the most main or major component of all these electronic chips is the transistor. Transistor is used to amplify signals, or it is used to switch on or switch off electronic signals. Transistors are small electronic components with two main functions. So we all have seen such type of device in the green colored chip which is present there in all these digital devices or our gadgets. This is a transistor. It has three wires coming out of it. What is the function of these three wires? We will just discuss. A transistor acts as switch to on and off electricity as well as amplify signals. This transistor plays the role that is placed by the traditional switch in the traditional bulky circuits. So it is used to switch on or switch off electronic signals in integrated circuits. Small and low power transistors are enclosed in resin case to help protect the internal parts. This is a resin case in which the small parts are there just to protect them, because those small parts are very delicate. We will just discuss the parts of the transistor. A transistor can be defined as a miniature device used to control or regulate the flow of electronic signals. Transistors are considered one of the major components of the most electronic devices today. The transistor was developed in the year 1947 by these three physicists. Parts of a transistor. Students, a transistor is mainly composed of three parts. One part is called base, the other one is called collector, and the third one is called emitter. But the names and the working of all these parts will be understood only when we go into the details. So let's go into the details. Transistor looks like this. It doesn't look like this. We are discussing the design of the transistor, how the transistor is made. Transistor is composed of transistor is generally called a triode. A diode is something which has two ends, but a triode is something which has three ends. I'll just draw the diagram of the transistor. So this is a transistor. A transistor can be of two types. Transistor can be of two types. First, let us discuss the types and then we'll get back to this. Types of transistor. A transistor is of two types. Number one, PNP transistor, and number two, NPN transistor. PNP transistor and NPN transistor. Now, what is the meaning of PNP and NPN? We all have studied about PN junction. So we know that there are two types of extrinsic semiconductor, N-type semiconductor and P-type semiconductor. So transistor is composed of three such semiconductors. Two semiconductors are of same type, which are present at two ends, and the middle part is of different type of semiconductors. For example, in PNP transistor, this is a P-type semiconductor, this is a P-type semiconductor, this is P-type semiconductor, but in between these P-type semiconductors there is an N-type semiconductor. And also in NPN transistor, this is N-type semiconductor, this is N-type semiconductor, and in between these two is P-type semiconductor. So PNP transistor and NPN transistor. So these two regions, which are on the either side of the middle region, are heavily doped, and the middle region is lightly doped. So one of these regions, the name of the middle region is fixed. The name of the middle region is base, right? And one of these regions is called emitter, which emits the majority charge carriers. We will just discuss what is the meaning of this statement. So emitter is the part of the transistor that emits the majority charge carriers, and collector is the part of transistor which collects the majority charge carriers, right? And base works as a medium between emitter and collector so that the majority charge carriers can flow from emitter to collector. But what is the meaning of all these things? We will just discuss. But first, let us discuss the circuit symbol of the transistor so that we can show the transistor in our integrated circuits without drawing this big diagram. So what is the circuit symbol? Circuit symbol of a transistor looks like this. Just draw a circle, and in this circle we will draw some straight lines like this. And these are the three ends of the transistor. Now I'll just get back to this, but let us again first study this circuit. We can see that there are three outputs of this transistor. One output is this, so this must be a wire which is coming out from this part, second wire is coming out from the base part, and the third wire is coming out from the emitter part. So that's why it has three wires coming out from it, and those three wires are shown in the symbol 1, 2 and 3. So the symbol of transistor looks like this, but there is a difference between the symbol of NPN and PNP transistor. Now an arrow is drawn between the emitter and the base region, and if the arrow is inwards, arrow is always drawn from P to N. So if the arrow is inward, so this is P and this is N, so that's why it is a PNP transistor. We don't have to write P, N and P on the symbol. I am writing just to explain you the concept, right? So this is PNP transistor. Now if you take another symbol, oh, I shouldn't have drawn this. A second, huh? Now we can group it. Now if the symbol is inwards, then it is a PNP transistor, because symbol is always drawn from P to N and in the emitter base part, and if the single is if the arrow is outwards, then it is an NPN transistor, because the arrow is always drawn from P to N. Now it has two PN junctions, right? One is this and one is this PN junction, and the middle part is common. So this PN junction is called the input PN junction, and this PN junction is called the output PN junction. input PN junction is forward biased and output PN junction is reverse biased. So we can clearly see that suppose this is a PNP transistor. This is a PNP transistor. So this is P, this is N, this is P. This is a PNP transistor. So this PN junction is forward biased because P is connected to positive terminal and N is connected to the negative terminal. But we can see that this PN junction is reverse biased because N is connected to the positive terminal and P is connected to the negative terminal. And in forward biasing we use a single cell, and in reverse biasing we use a battery. We all know this, right? But why the input junction is forward biased and the output junction is reverse biased? That can be explained in the working of the transistor. So why this input junction should be forward biased? Now let's study the working of the transistor. To make this transistor work properly, input junction should always be forward biased and output junction should be reverse biased. But why? Let's see. Working of a transistor. Working of a transistor. I am discussing the working of PNP transistor, and based on that you can understand the working of NPN also. So let's discuss the working of PNP transistor. PNP transistor की working. We know that P-type semiconductor is, this is emitter, this is base, and that is collector. Okay, now let's erase this so I can explain the working. So this is a P-type semiconductor, and in P-type semiconductor the majority charge carriers are holes. In P-type semiconductor majority charge carriers are holes. This is also a P-type semiconductor, so majority charge carriers are holes. And this is N-type semiconductor, so majority charge carriers are electrons. But as I have told you, this is heavily doped, this is also heavily doped, but this is lightly doped. In a typical semiconductor, base region, doping of base region is just 5%. Doping of base region is just 5% as compared to emitter region, as compared to emitter region and doping of collector region, doping of collector region is 95% as compared to base region, as compared to base region, sorry, emitter region. Okay, what is the meaning? Suppose if we have 100 holes in the emitter region, then compared to those 100 holes, there are only 5 electrons in the base region and 95 holes in the collector region. So that is the meaning of this. These figures must be remembered. Only then you will be able to understand the working of the transistor, right? Okay, now let's start. Now if we switch on this input circuit, this is a positive terminal of the battery, and this positive terminal is going to repel the holes in the emitter part. Let us say it repels 100 holes towards the base region, right? And 100 holes reach from emitter to base part. But since the doping of base region is very small, so when the 100 holes reach in the base region, all the holes are not going to pair with the electrons present in the base region. Only 5 out of these 100 holes are going to combine with 5 electrons of the base region, and 95 holes will move towards the collector region. Now we can clearly see that this region has emitted free charge carriers, and this region has collected the free charge carriers, and the middle region is just working as a base so that the free charge carriers can travel from emitter to collector. Hence we have named them emitter, base and collector. Now when the 5 holes from this region combine with the 5 electrons in n-type, this base region, so what happens? 5 electrons, all these semiconductors were neutral, right? Initially these semiconductors were neutral, but when the 5 electrons get combined with the 5 holes from the emitter, so this region will become slightly positively charged, because now it is losing electrons. So it becomes positively charged. So this negative terminal of the battery will start giving this positive region 5 electrons, and due to which a current will start in this region, and that current is called the base current, which is denoted by IB, right? Now, when 95 extra holes reach in the collector region, and collector was also neutral before this, so when 95 holes reach this collector region becomes positively charged, and due to this positive charge, this negative terminal of this battery is going to provide 95 electrons to this region. We are just assuming these figures. I am just taking these examples like 100 holes, 5, and just to make you understand the concept. In reality, these are millions and trillions of holes and electrons, right? So 95 holes go from the negative terminal of this battery to this region, and due to that a current will start in this region in the opposite direction, and that is represented by IC, which is called the collector current. Now these 95 electrons will neutralize the 95 holes that came into this collector region from the emitter region, and again this emitter region becomes neutralized. But when the 100 holes went from emitter to this emitter region becomes what? It becomes negatively charged, because it has lost holes. So this negatively charged region will start attracting positive charge, or we can say that these electrons which are extra electrons, because this region was neutral before, but when the 100 holes went into that region, 100 extra electrons were there, and due to the attraction of the positive terminal of this battery, 100 electrons start moving towards this positive terminal, and due to which a current will start in this region, which is denoted by IE, and which is called the emitter current. Now at any given instant, this current is due to 5 electrons, this is due to the 95% of the electrons, and this is due to 100% of the electrons. So we can clearly see that IE is equal to IB plus IC. This is a very important relation in the working of transistor. This is a very important relation in the working of transistor, that the sum of emitter current is equal to the sum of the emitter current is equal to the sum of base current and collector current. And IB, that is base current, is 5% of IE that is 5 by 100 IE, and IC is 95% of IE, that is 95 by 100 IE, right? Okay. This was the working of NPN transistor. Based on this, you can think about the working of NPN. This was the working of PNP transistor, and based on this, you can also get to know the working of NPN transistor. If this region is N-type semiconductor, this is P-type semiconductor, this is N-type semiconductor, this is forward bias. Okay. Now, since we have studied the working of the transistor, now we can easily understand that why the input region should be forward biased and output region should be reverse biased. Because if the input region is not forward biased, it is not going to emit holes. The holes were emitted only when, because this was forward biased and the positive terminal of this battery start repelling these holes. But if this region was inverse, this region was reverse biased, then the working of transistor would not have been started, because there will be no repulsion between the positive terminals and holes of the emitter region, because then it is connected to the negative terminal, and negative terminal is not going to repel these holes. So the working for the correct working of the transistor, this input junction should be forward biased so that it can repel majority charge carriers, and majority charge carriers start towards the collector region, and collector region should be reverse biased so it is able to attract or collect the majority charge carriers towards itself. Now, in the working of transistor, we can clearly see that a current is always maintained in the external circuit by electrons and in the internal circuit by the majority charge carriers. Extra holes and electrons are being produced in the emitter region by the breaking of silicon bonds. When a bond breaks, a pair of electrons releases and two holes are released, and those holes and electrons are involved in the working of this. The connection that we have shown here is called common base configuration, because base is common in input and output region. Similarly, emitter can be common to input and output region, that is called the common emitter configuration, and collector can be common to input and output region, that is called the common collector configuration. Now we are going to see each of these configurations, starting with the common base configuration. This is the configuration that we have just studied, where the base is common to both input and output circuits. Here you can clearly see that this is an NPN transistor which is connected in common base configuration. So this is the base, and this base is connected to the input region as well as to the output region. So the input region is the emitter base junction and output region is the collector base junction. So this type of connection is called common base configuration. This is the type of connection whose working we have just studied few minutes ago. Secondly, so a common base configuration is a configuration where the base terminal of the transistor is common between input and output terminals. Second one is the common collector configuration. In a common collector configuration, the collector terminals are observed to be common between the input and output terminals. In common collector configuration, collector is common to both input and output. Now, to clearly show this common collector configuration, we have rotated this transistor like this. Now, this is the collector terminal. Here we have shown an NPN transistor in common collector configuration. Now this is the base region, this is the emitter region, this is the collector region. We can clearly see that the base region is connected to only the output but not with the input, and the base region is connected to only input, but the collector region is connected to both output and input. Just like the base, was here, base was connected to both input and output, and here we have collector connected to both input and output. So this is called the common collector configuration, where collector is common to both input and output terminals or junctions. Now the third one is the common emitter configuration. All these configurations have separate uses. Common base configuration is used in amplifiers. Common emitter configuration is also used in amplifier. There is a difference in the amplification. When the transistor is used in common base configuration in amplifiers, the amplified voltage is in the same phase. But when the transistor is used in common emitter configuration in amplifiers, the amplified voltage is with a phase difference of 180 radians or pi radians, not 180 radians, 180 degree pi radian. If this is the input voltage, common emitter is going to give you the output like this. So the voltage is amplified, but the phase also changes. But in case of, if you use common base transistor for amplification, you will get the output voltage in the same phase, right? So there is a difference in the working of all these configurations. So we use this configuration for different purposes. That's why we need all these three. So in common emitter configuration, in this type of configuration, the emitter terminal is common between the input and the output terminals. Here we have shown this emitter. Now this is the collector. This is connected only with the output. This is the base, which is connected only with the input, and this is the emitter, which is connected with the input as well as with the output. So these are the three configurations in which the transistor can be connected in a circuit. Applications of transistors. So where these transistors are used? Transistors are used for making memory chips. All the digital devices that we use, like mobile phones, like laptops, like tablets, they all have memories inside them. We measure that memory in GB, right? 500 GB, 1000 GB. So that memory is stored in a chip, and that chip is made with the help of transistors. Transistors are used for making most of the part of modern electronic devices like smartphones, smartwatches, etc. All these modern electronic devices like smartphones, like laptops, like this smart board, like your smartwatch, tablet, all these devices has chips in them, right? And one of the major component of that digital electronic circuit that is there in all these devices is the transistor. It is used for microprocessor and microcontrollers. What are microprocessors? All these devices run on some kind of processors, and those processors are the microprocessors because they are used to run the microelectronics. So transistor is a major component of those processors. When a large current or voltage is needed to be controlled, in Darlington transistor can be used. Darlington transistor is beyond the scope of this video. We are not going to discuss particular type of transistors in this video, but whenever a large current or voltage is to be controlled in digital electronic circuits, a transistor is used. You will study more about the transistors in coming videos. Transistor switches can be used to switch and control lamps, relay, or even motors. One of the major uses of the transistor is the switching purpose. These are used in microelectronic circuits to switch on or switch off the current and voltage. Okay, now why should we use transistors? What are the advantages of transistors? Advantages of transistors are obviously बहुत ज़्यादा advantages होंगी. That's why we are using them in so many devices, or they have so many applications. So one of the most important reason is the lower cost of the transistor. Transistors are very cheap because, as we have already studied, that in a single very small chip there can be thousands or even lakhs of transistors. And what is the cost of that chip? All those chips are there in our smartphones. And what is the cost of the smartphone? For 5,000 to 10,000 rupees is the cost of the smartphone. So you can get an idea, or you can just easily do a calculation to see what could be the price of a single transistor. So they are very cheap. They are smaller in size. So day by day they are helping us make compact digital devices that can be fitted in our pocket. We are using mobile phones with many features. 30-40 years ago, one could not even imagine that we can have such a small device which can perform such a large number of functions, that that device can be fitted into our pockets, and that is possible only because of the transistors. Smaller mechanical sensitivity, lower operational voltage, very small voltage is needed to operate them. They all are being operated with the help of the battery which is there in mobile phone or smartwatches or laptops, and the voltage of that battery is very small, and so all the transistors are running on that voltage, so they need very lower operating voltage, can develop better efficiency circuits, and can be used for a single integrated circuit. Disadvantages of transistors. What are the disadvantages? Obviously there must be some disadvantages. Disadvantages of transistors. Transistors are temperature sensitive. A small change in temperature can damage the transistors. That's why it's written on mobile phones that we should protect them from extra temperature changes like heat or cold. Helps to yield very low energy. Okay, transistors can be used to perform those functions in which small energy is needed, like the functions which are performed by our digital devices. But transistors cannot be used to perform those functions in which large amount of energy is needed. Like transistors cannot be used in geysers, in heaters, in air conditioners, in refrigerators, because these devices need very high energy. It lacks a higher electron mobility. Okay, what is a mobility? Mobility, we studied mobility in third chapter. Mobility is represented by mu, that is the velocity of a charged particle per unit electric field. Velocity of a charged particle per unit electric field. Higher the mobility means that the charged particle whose mobility is higher can be easily made to move. If the mobility of electron is higher, that means that a smaller value of electric field can provide a larger velocity to the electron. But the mobility of electron in a transistor is very low as compared to the traditional circuits. Transistors are very easily damaged when electrical and thermal events come up. That is almost the same point as the temperature sensitivity, but apart from temperature, there are other factors also that can easily damage the transistor, like the electrical and thermal event. Thermal event means when the heat energy is increasing, and electrical event means sometimes when some more current comes. So हम कहते हैं ना कि हमारा डिवाइस जो है जल गया, फूंक गया. So what does that mean? That more current damages the transistors. That's why the device stops working. Transistors can be extensively affected by cosmic rays and radiation. We all know about cosmic rays and radiation, the rays that are coming from outer space on Earth, like the electromagnetic waves, like the dangerous electromagnetic waves like X-ray, gamma rays, and they are very sensitive. Transistors are very sensitive to these radiations. A small change in the intensity of these radiations can damage the transistors. So this was everything about transistors that can be discussed in one video. Transistor is a very big topic. There are lots and lots of other things that we should know about transistor, but this was just for the introductory part. So I have discussed all the important things about the transistor. I'll meet you in the next lecture. Till then, all the best.